Okay, let's talk about some other types of equations. We've covered linear and quadratic, but we might encounter some other types of equations along the way. And so that's what I want to go over with you a little bit here. And these are going to be, let's call them third degree, third and fourth degree equations. What do you think I mean by that? Third degree, fourth degree. X to the third, x to the fourth. Yes, we're talking about x to the third, x to the fourth equations, and you know it could extend beyond those. We're just going to tackle the ones basically that we can use factoring on at least a little bit, and then maybe some other methods. But so yeah, just take a look at one here: x cubed plus 4x squared minus 12x equals 0. So we've got the x cubed, third degree, largest power is 3, so it's a third degree equation. All right, well, like I said, we're looking at ones here that at least at the outset of the problem, we can use a little bit of factoring. So what do you see? Take an x out. We've got a common factor, don't we? We've got a GCF of x. You don't necessarily have to write that, but understand I'm looking at, I've got a common factor of x in all of those, and so yeah, I'm going to pull the x out. And what does that leave me? If I pull x squared plus 4x minus 12, yeah. All those divide by x, and so we've got in parentheses there that trinomial. All right, now we could go ahead and say, well, I've got it factored, so I could set them equal to 0. However, I notice, what else can I factor here? Can I factor this trinomial? Where I can at least think about it. I didn't exactly check. Yeah, that's going to factor, isn't it? A pretty easy one, because you got x squared here, so you know that's x and that's x. And then you got minus 12 for these two. And then the middle needs to be 4, so that's going to work, isn't it? 6 and 2 for the 12, because that's a minus, so one of these is negative, so I'm actually subtracting them to get, and so that gives me 4 there. Now which one's going to make it a positive 4? Plus 6 and a minus 2. And of course you can fold that back out and see if it works, but I'm good with that. Is that okay? Sound all right? Yeah, so now we've got it all set up, don't we? X equals 0, x plus 6 equals 0, x minus 2 equals 0. One of those factors has to equal 0, so we're going to set them all equal to 0 and see which values of x make them 0. Of course, that one's done. Subtract 6, 6, and add the 2, and we got 2. How many answers?
3.
We got 3. Yeah, third degree, 3 answers. Okay. Yeah, those tend to match up, the degree on the equations, the degree and the number of solutions on one variable equations anyway. All right, well, what about, is that okay? Any questions on that one? We good? 8x to the fourth minus 22x squared equals 0. And one thing we haven't mentioned yet or talked about yet, but since we are using factoring, for this to work, one side has to be 0. And both of these examples, so far we've had one side has started out as 0. So, but if one side isn't 0, make one side 0. Okay? All right, well, what do you got? Any factoring?
X squared.
I can bring out an x squared, and if we see it, we could go ahead and do a little more. 2. We bring out a 2x squared. The x squared is the main, but the 2 will help as well. But anyway, so if we bring out 2x squared, that'll be 4x squared minus 11.
Yes.
Okay. All right, well, Problem with now factoring this is, yeah, when you've got two term binomial to factor, you need both of them to be squares for it to factor with the integers. That one's not a square, so we're kind of...
Is that the answer then, for now?
For now, no. So for now, what we can do is, instead of factoring again, we can just do our equal 0. Because we do have factors. Two factors, the product is 0, so we can set both factors to equal to 0. We could have done the same thing over there, and it would have worked very much the same, but yeah. Since we're at the end of our factoring, just go ahead and set them both equal to 0. Now this one is a much easier equation than the second one here. Just divide by 2, right? And x squared equals 0. What do you got there?
X equals 0.
Yeah, that's going to be x equals 0. Now, we might note there, for the purposes of seeing how many solutions we got, that's a double solution there, because if you think about it, it's x times x. So you've got x equals 0 twice. So that's a double solution, sometimes we call it. So it's 0, and we could say it's a double solution. Now over here, on the other hand, similar, I'm going to use the square root method, right? I can't factor it, so I'm going to use the square root method. Add 11, divide by 4. 4x squared equals 11, then divide that by 4. So we've got x squared equals 11 fourths. And that's where our square root method comes in, square root both sides. More or less what we're doing here. The only catch is what?
Fraction.
It's a fraction, but what other thing do I need to add here? The plus or minus, yeah. In that square root method, when I square root both those sides, this, usually the right-hand side, the number side can be a plus or a negative. There's two solutions there, the positive and the negative of that. So yeah, you get x, because the square and the square root cancel out. That's a pretty good answer. We could do some approximations, but we can simplify this a little bit because we can split that up, meaning take the square root of 11, square root of 4 separately, because the square root of 4 comes out nicely to be 2, right? So if you can do that, that's what we want to do. Yes? Look okay? Question? Question or concern? All right? All right. All right, here's another one. X to the fourth minus 2x squared minus 24 equals 0. X to the fourth minus 2x squared minus 24 equals 0. So again, we have a fourth degree equation. However, unlike the previous two, we don't have a common factor, do we? No common factor there. Well, now let's look at other types of factoring. The way I look at it, I've got a trinomial, and it's, I don't have one up here, but you know, when I have a trinomial, one way I look at, besides common factor, is I look at breaking that down into two binomials, to the parentheses there. Yeah, and so some of these, even though it's x to the fourth, those can be broken down very similar to the, if I had an x squared there, okay? The only deal is, I'm breaking down x to the fourth here and here, right? So, how do I do that? I guess there's a number of ways, but probably the way I would do that would be x squared and x squared. Yeah. Break down the x to the fourth as x squared and x squared. Then I've got a similar situation as before. The minus 24 I need to factor into those two slots and get a minus 2 in the middle. Same thing there. It's 24, 2 in the middle, or minus 24, negative 2 in the middle. What do you got?
4 and 6.
4 and 6, okay. And it's a minus 2, one of them's a minus, so it better be the minus 6, okay. All right. And so we run out of factoring there because, oh, yeah, that's it. Brings up a good point. We talked about on the binomials, these two need to be squared, but it also needs to be a minus. It needs to be a difference of squares for it to factor. You can't factor a sum of squares. Here again, 6 is not a square, so kind of stuck on the factoring. But we do have it factored into product of two things equals 0, so we can go ahead and set those separately equal to 0, can't we? And then solve them with the square root method. Said that square root method comes up quite a bit here. So I'm going to subtract 4. Then square root both sides. The right hand side can be plus or minus. All right, so now we encounter our first encounter here with the negative square root. I believe it's our first encounter. What do you got there? Yeah. Yeah, that brings up the definition, we call it, of the number I. I equals the square root of -1. And so I've got it, didn't think of it there. Yeah, I've got a square root of a -1 here. Well, the square root of a -1 is I. That's just by definition what we call it. And then, of course, you got the square root of 4. So I believe somebody said it. Yeah, that's 2I right there. Plus or minus 2I. Oops. For that, so those solutions there. Is that okay? Question or concern on that? What about this one over here? Add the 6. So we don't have the I on this one, but square root both sides and make the right hand side plus or minus. So I got plus or minus square root of 6 there. Is everybody okay with that? Yes? Yes. All right. So there's our four solutions. 4th degree, 4 solutions. I didn't mention over here, but this one too had 4 solutions, didn't it? Because that was a double solution, 2 zeros, if you will. All right. Question? All right. Let's see here. Yeah, let me show you this one. All right, 4 over x to the 4th minus 11 over x squared minus 3 equals 0. Give us a little more practice. Those sometimes are a little tricky, but yeah, this one, we talked about this one before also. Well, one with fractions, and we talked about that multiplying by the least common denominator here on both sides. Yeah, that's one way to go at this one. The least common denominator on this one would be, well, what would it be?
1.
Well, you got a denominator of x to the 4th, you got a denominator of x squared, and there's a denominator of 1 there, and so x to the 4th, wouldn't it? X to the 4th would be the least common denominator, the multiple that is a multiple of all of those. Yeah, it'd have to be x to the 4th. You need that x to the 4th there. Okay, and so multiply then both sides by x to the 4th. Essentially, multiplying the whole equation here by x to the 4th, kind of save myself. So what that's going to mean is all 3 of those get multiplied by x to the 4th. So we got x to the 4th, I'll write it out. X to the 4th times 4 over x to the 4th minus x to the 4th times 11 over x squared, and then x to the 4th times 3, and then of course x to the 4th times 0. We are doing that, but of course that's 0. Now there is some nice things happening over here on the left too. What happens here? Yeah, 4. The x to the 4's canceled because you got that's in the top, that's in the bottom, they cancel. In the middle here, well, they don't cancel entirely out. The x squared goes into the x to the 4th and leaves me an x squared, doesn't it? So that's 11 minus 11x squared in the middle. And then nothing cancels here. Okay. All right, well, so this one, here's what I can do. here's what I can do for this one. This one is going to set up very much like this one. Let's just move all these terms over to make this one positive. So let's subtract the 4, add the 11x squared, and add the 3x to the 4th. Both sides. And then let's write them in order. 3x to the 4th plus 11x squared minus 4. Okay? Yeah, so that one's going to set up pretty much like our one over here on the left side. It's a trinomial, there's no common factor. We've got a 3x to the 4th, so what am I going to put here and here? Probably 3x squared and an x squared, yes. Now, with that being 3x squared, I can't really think about what factors go here and here that add up to be 11. I call it, you have to look at the OI, the two, the outer and the inner terms. Yeah, but I believe, looking at this, I believe a 4 is going to go here and a 1's here, and I'll tell you why. And it's going to be a positive here and a minus here. I tell you why, because that and that are 12x squared, and that are minus 1x squared, aren't they? Mm-hmm. And so that makes the 11. And so you just have to kind of try and see what works out there. All right, and so yeah, then we've got 3x squared minus 1 equals 0, and a little more room here. And x squared plus 4 equals 0. Whoops, that's minus 1. 3x squared minus 1 equals 0, and x squared plus 4 equals 0. Yeah, so those are just square root methods again. Add 1, divide by 3. So x squared is 1/3. X then would be plus or minus the square root of 1/3, right? Mm-hmm. And that's not going to simplify any nicely. So, and over here we got the same thing we had in that previous one, isn't it? Subtract 4, square root method. So you got plus or minus square root of negative 4, so that's plus or minus 2i. So, anything I had. Okay? Question? Good with that? Are we okay? All right. Okay, just a couple of others here. Show you the square root equation. Yeah, let's talk about square root equations, just in case one of those happens to creep up on us along the way somewhere. Well, most basic one would be like a square root of 5x plus 4 equals 8. Okay. Yeah. On a square root equation, the basic idea is to get rid of the square root. I want to be able to get rid of a square root, and they can get complicated pretty quickly, but this one's a fairly simple one. And the technique here is, on this one, is just square both sides. Now, why does that work? Square both sides, right? Because on equations, you do the same thing to both sides. You're usually in good shape there. Okay, well, this works because what happens on the left side over there?
Doesn't the square root cancel?
Square root and the square cancel. Yeah, we've talked about that a little bit. But yeah, that's why we square both sides, because that's going to cancel out the square root and make it 5x plus 4. And of course, on this side, we do have a 64. It doesn't cancel out, just it's 8 squared, 64. Now it's just a linear equation. So that's the goal, is to get rid of the square root. Then you can solve it like you have other equations. Yeah, x equals 12. Now you do have to be careful. Make sure make sure it works. Check that to make sure. If you plug in 12 there, yeah, you get the square root of 64, so that's going to work. Just want to make sure, because sometimes you can get, with this technique, a little extraneous solution. Sometimes. Okay. Now, what about this one? Square root of 4x plus 33, and then minus x on the same side, and then 3 equals 3 the other side. Square root of 4x plus 33 minus x, and then equals 3. Okay, now, you have these little rules here, but for this squaring both sides to work, you need one side to be just a square root. And so in this case, I've got square root, but then I have an extra piece there. And so I've got to get the square root by itself. So I'm going to add the x here first of all to get the square root by itself. Now, and then the other complication, that doesn't combine. It's just x plus 3, isn't it? Or 3 plus x. But we do have the square root on a side by itself. And so we can do our squaring of both sides now. And the square root and the square, this side works out nicely. Now this side, well, the problem with that is, it's a little more complicated, is it? But all you have to do on this side, if you know the rule, that's a shortcut, I guess you might call it. You can do that, but really what this means is, isn't it x plus 3 twice? And so what I've got there is not x squared plus 9, that's part of it, but I have a little more to it than x squared plus 9 because it's x plus 3 times x plus 3, so what do I have to do to that?
Foil it.
Yeah, we call it FOIL, different names. We've got to multiply that out. So you go x times x is x squared, x times 3 is plus 3x, plus 3 times x is plus 3x, and then, yeah, so you got a little more than just x squared plus 9 on that side. So you've got 6x in the middle. All right, now, what kind of equation do I have now? Because when I did the squaring a while ago, I wound up with a linear equation. This one is an x squared equation. So how do I do that? Well, I use factoring, I use square root method, I use quadratic formula if I have to. What do you think on this one? Probably factoring. They probably will be nice to us and set it up where it's factoring. It may be something else, but to use factoring, I got to make one side 0, don't I? So let's bring these terms over. Make this side 0. What does that make this side? X squared. We have 6x minus 4x to be plus 2x. And then 9 minus 33, negative 24. Does that look right? Believe that? Yeah, I believe that factors then. 6 and 4 again. Positive 6 and a negative 4 gives me positive 2 in the middle. So I've got a negative 6 and I've got a positive 4. Now, I believe this is a good one to demonstrate the fact that I better check these. Because if I plug in a negative 6 here, what is that going to give me? Negative 24 plus 30, that's going to be the square root of 9. So I have the square root of 9 minus a negative 6. Does that equal 3?
No.
No, it doesn't. Because that's going to be 3 plus 6, that's going to be positive. Yeah, so that doesn't work out. So that's what I'm saying. Sometimes you get extraneous solutions when you use these squaring of both sides. 4, I believe, is okay.
So in a situation like that, with us pushing all our work down and showing it, you want us to just circle the x plus 4? Or do you want us to circle?
Yeah, just circle the one that's
Works.
correct.
Okay.
Mark out would be the best idea on that one, so I know you. So I know that you know that one doesn't work. 4 does work, doesn't it?
Yes.
Square root of 49 minus 4 is 3. Okay? Yes? Okay? All right. Well, that should get us started anyway on the solving types of equations. Let's talk about a little bit about graphing here. Like I said, this course is a lot about graphing. Erase that so quick. So let's talk about graphing. Let's do a little bit with graphing two equations, an equation in two variables. That's what we're going to be about here. Equation in two variables. For example, let's start with, let's just start with y equals 8 minus x cubed. So I want to be graphing that. And you may know a little more about it than we're going to get into right now. We'll talk a little more about this one, specifically things that happen to this graph later. But for right now, we're just trying to graph it. And what we're going to do here is using a table. Because as you know, hopefully know, graphing really amounts to graphing pairs of solutions, right? Because here, like one solution would be 2, 0. All right, we're going to graph that point on the Cartesian coordinate system, the xy plane. Okay, so we need to get these pairs of solutions. Ordered pairs is what we call them. All right. Now here's the ones I'd like for you to use, starting off with, just so we get a pretty good idea. Sometimes these may not be the best ones to use, but let's just pick out x values. And in this case, I'm going to pick out x to be -3 to +3. Okay.
Can I ask why you chose those numbers?
They're just kind of middle numbers, yeah. Like I said, those won't always be the best ones to use, but for now,
Okay.
the ones that we graph, those will be fine. You may need others, but we'll just start with tables using that. Okay, well, then of course it's just a matter of figuring out, well, I plug in -3 there. What have I got? It's 8. Be 8 minus -3 cubed be -27, so that's going to be a 35. It'll be 8 plus 27. All right, with me on that? Then a -2, so plug in the -2 there for x. That's all I'm doing, is just plugging in the x value. What does that come out? 8 minus a -8. 16. 8 plus 8. -1. 8 minus a -1 cubed, so that'd be 8 minus a -1. 8 plus 1 would be 9. All right, then it gets a little easier with the positive ones, 0. 8 minus 0, so that was going to be 8. X is 1, we'll have 8 minus 1, 7. And 8 minus 2 cubed, be 8 minus 8, that'd be 0. And last but not least, 3, 8 minus 3 cubed, so that'd be 8 minus 27. I believe that's -19. Anybody believe that? Out here. All right. So yeah, we put those on then our Cartesian coordinate system. And, you know, they may have, I do have a worksheet on this one, so you may already have prescribed scale and can alter it if you need to. In this case, we're going up to 35 and down to negative 19 on the y value. So on the xy plane there, we need to go to 35, and let's go by 5s. Gives a pretty good idea there. It's 5, 10, 15, 20, 25, 30, 35. And then down negative 5, 10, 15, 20, 25s. We'll scale these by 1. All right? Yeah, so we've got the Cartesian coordinate system set up there. Okay? Yeah, so these just gives us points. This one's a negative 3x, positive 35y, so we go to negative 3 in the x, and then 35 in the y, so it's up there. A negative 2 and 16, so 15's here, so 16. I'm going to say is right about there. And negative 1, 9. Okay, right there. 0, 8, a little bit lower. 1, 7. Those are pretty close there. And then 2, 0. And 3, negative 19. Okay? Just plot those points. Question? Everybody believe that? All right, well, yeah, we've just plotted just a very few of these points, but I think we can get a good idea here because can we kind of connect the dots here? So we at least got that. What do you think happens on the outsides, if you will? Looks like it's going to keep going up there and down here, right? So, yeah, in this particular case, these points give me a pretty good idea of what the graph looks like. All the other points should fall in line with what we've got shown here. Okay?
Would it be wise to bring graph paper in the future?
Graph paper? Graph paper's great. Yeah, bring, if you would like to use, you don't have to, it's not a requirement, but graph paper would be fine. Like I said, I've got a worksheet for this, and it does have a little grid for you already, so yeah, graph paper would be super. All right, so same thing, let's do graph y equals absolute value of x plus 1. Same table, negative 3, positive 3. Sometimes more, sometimes less are needed, but for now, that's what we'll use. Okay. All right, what do we got? For negative 3 plus 1, absolute value. Positive 2, yeah. The absolute value of negative 2, which is positive 2. The absolute value changes into positive. All right, then negative 2 plus 1, that'd be 1. Negative 1, what's going to happen there? 0?
0.
And then 0, these get a little easier. 1, 2, 3, and 4. Did I do those right? Real quick. Just plug those in. X would be 0, 1. Yes?
Yes.
Mm-hmm.
All right. Okay. So, not quite as spread out as that other one, so we'll just go by ones here. All right, we got a negative 3 and y is 2. So negative 3, y is 2. Negative 2 is 1. Negative 1 is 0. 0 is 1. 0 goes with 1. 1 goes with 2. And then x is 2, y is 3. Oops. Yeah, that should have been higher. And then 3 goes with y is 4. Yeah, so those give me, well, it looks like we got a V shape, and yeah, I think continue the pattern out here, we check more, but I believe we've got a V shape. You may know more about this one right now than we're talking about, but the idea is just get a little graphing in, and we'll go from there at a later date. All right? Now, let's talk about specifically here a couple of things, and that is the intercepts. We have what are called the x and the y intercepts, and those are very easy because the x-intercept just means you're intercepting the x-axis, right? You're crossing the x-axis, so that's the x-intercept. So here our x-intercept, we write it in the ordered pair form, would be x is 2, y is 0. Over here the x-intercept is negative 1, 0. Yep. And then the y-intercept, like I said, that's where it intercepts the y. So what is the y-intercept over here? Crosses the y-axis, 0, 8. And over here, the y-intercept is 0, 1. Yeah, so the x and y-intercept, very easy definition, is just where it crosses the x or the y-axis, respectively. All right? Okay. Yeah, but what we want to be able to do is identify these without having the graph. Sometimes you may have the graph and then identify the intercepts, but a lot of times it goes the other way. We have the equation without the graph. How do we find those intercepts? Well, we note here on the x-intercepts, a common feature of that is going to be, in both cases we've got y is 0, and if you think about it, that's always going to be the case. For the x-intercept, the y is 0.